because we want you to succeed, but there's also obligation on your part to respect the instructors and to keep up. I wanted again to congratulate Vulcan, who has done all the certificates so far, or rather badges. Does anybody want to share how far they've got? Do they have any challenges? We do have office hours with more Google developer experts in machine learning who will be joining us. We had a Googler speaker, so we want to have the best experience for you so you can truly upskill yourself and become an ML engineer and really bridge that gap, because there's so much demand now, right? You've seen everything going mainstream pretty much with ML and AI. So who wants to share? Victor also shared his profile recently. He's also doing well. Who wants to share how far they are? 'Cause I didn't have a chance to. There's like over 120 profiles. I checked maybe 1/3, and some people haven't even started. So that's not a good situation to be in, because it's gonna get only harder from here now. Yeah, so please, anybody share if you have, for example, somebody had a problem with the labs themselves. I believe at this point everyone has access. I've been in touch with the support team, and they're also very responsive to make sure everyone is set up for unlimited credits and labs. Morrison is the OG member of GDG. Morrison, how far have you got with your labs?
Still trying to progress, behind but trying to catch up.
So are you done with session 1?
I'm in the middle. Actually, I'm not even sure where I'm in the middle in right now. So I'll have to review where I stopped, and I'm gonna have to pick it back up.
So I'll share Vulcan's profile so that you see what you need to have already accomplished. So all these things are part of the session 1 or session 2. I believe feature engineer, you've done some extra credit here. So I've also shared them in the chat. So we had time off, so please keep on track. As you know, we'll be giving away vouchers, exam vouchers, which are worth $200, and we'll have a graduation party. That's always fun in person with those who are in New York. And who else wants to share? Paul is also a very active GDG NYC member. Hi, Paul. ML pipelines, okay.
How y'all doing?
Am I audible now? Sorry. Hello?
Hi,
Hello?
Aurora. We can hear you. That's fantastic progress.
Perfect. Thank you. I just want to say it. Thank you.
So, this is Maddie here. I don't know if you guys can hear me.
Yes, we can hear you.
Okay, alright. So, we're like giving you a little bit of tough love, right? But this is honestly because we know this is hard and because we know how much work there is. And we just really want to see you succeed as long as you want to succeed, right? So don't let this discourage you. You still have time to like catch up. We're like only halfway through, but we're also already halfway through, right? So I'm just, instead of like making you more stressed, as instructors, we want to be helpful. So what has been the biggest barrier in, people kind of like getting things done? Is it just because it's a lot of time and everything's new? Are there things that we can do that would, help you make progress? Because I would love to see all of you succeed. Like, this year or next year and become like professional ML engineer certified by Google. But yeah, so feel free to share any like struggles in the chat and all of that. And while people are sharing, someone asked the question about why does AutoML take such a long time? It takes a long time because it's not that the data is necessarily the causing the problem. It's the fact that AutoML typically uses a method called ensemble learning, and what that means is that it's building multiple different models for different scenarios. And one of the downsides of using AutoML is called the ensemble to death, right? What happens is that you have typically like the main model, and it kind of decides, okay, which sub model do I want to call, or which sub part of the network do I want to use. And because it has so many different cases, you're building like a different kind of smaller models for each like sub case. It's up being like very like compute intensive, right? So unfortunately, AutoML takes a lot of time to train, and sometimes the models are actually fairly brittle. I think depending on what input you're using, the behavior is not super consistent. And sometimes because the model size is so large, inference actually takes a long time too, right? So there's pros and cons and trade-offs. And this is why, yes, like we do have AutoML, we even have neural architecture search, as in the model will actually figure out how itself should be structured to better solve your problem. But nothing beats actually understanding machine learning and being able to surgically build a model that you want, and that is the most effective, right? So it's just like if I want to New York and meet you folks, like I can take an airplane, or I can take a rocket. The rocket will be overkill, right? That kind of situation. But yeah, hopefully that helps. I'm just checking to see if people like responded about like what else we can do to help and like why it's being so challenging. But yeah.
Thank you, Maddie. And I open the Q&A so that your questions don't get lost in the chat. So if you want, you can put your questions there. So there is a lab that has a problem. So if you have seen our latest document, the learning journey, we have removed one actually the one we're going to cover today, session 3. There has been these labs, they sometimes give problems, things get updated, they're not up to date. So for session 3 we have revised the learning journey. Let me share my screen again. So one moment. Okay, here is the window to share. So this is what you should be completing. Of course, you're welcome to complete anything, but this is the priority and part of the course. So here, session 3, there was one more hands-on lab that we have removed because there was a problem. As far as I know, everything else is working. Roya, is there anything that's not working that's on this list?
Yes, the labs for next week. So both of them actually fall into the second half. Session 4, the labs for computer vision are under review. And in session 6, the labs for, if I'm not mistaken, MLOps are under review. So I'm actually working.
For this week, which one has a problem?
For this week, session 3, everything should be good to go.
Oh, session 3 is all good. Okay. Okay. So, people were talking about computer vision, which is session 4. Well, it's good to hear if you're ahead in session 4. That's amazing.
I'm working on session 4 right now. I got an update that they have been fixed. I haven't checked yet, but I know there were issues because previously TensorFlow 2.6 was not available as a part of Vertex AI. It has been removed to an update, but they brought it back.
Oh, for which session is that?
For session 4.
Okay, so the one that we removed from this week, though, that's still not working, right?
Yes, that's not existent.
Oh, it's not existent altogether. Okay, so we're good. Fantastic. So before we move on, we have a couple more announcements. Well, first of all, I published the office hours. We are going to have another researcher and Google developer expert, Rabimba, who'll be joining us to answer any questions that you may have and get help. And Roya today will cover session 3. So yes, we're not quiet at the halftime, but after this week we will be. So yeah, please make sure to keep up. And one more thing I wanted to share is another opportunity that we talked about last time. So I rarely endorse anything, but Super Momo's CEO loves our community, and Super Momo's is truly, I mean, I believe our events are always great, very professional, elite, with super speakers and great experiences always. But Super Momo takes it to the next level. Their events are very curated, invite only, so they're usually you meet people that you'll be thrilled to meet. So the CEO of Super Momo has made a special opportunity for GDG NYC. There is a Super AI ML Summit next week on July 14. Let me share my screen for that. And it's invite approval only. Everyone who is anyone in the AI ML world will be there. We usually have great Google speakers, but there'll be people from Meta, from the financial industry, founders, VCs, investors. So it's truly a great opportunity if you're looking to network, to meet speakers, to get hired. So it's not a free event, but they gave us 40% discount, and the price is actually going up as we speak. The reason it cannot be free is because it's in the middle of Times Square. It has breakfast, lunch, happy hour, coffee, networking. Like I said, it's very curated. So here are all the speakers. And there will be also opportunity to meet different communities. For example, there'll be GDG community, JP Morgan community, and so on. So if you have a chance, I highly recommend going. Last time I asked what would be the price you pay. So the tickets are $500 now, but we do have a code that will give you a discount of 40%. So you pay $300, and also you don't have to be approved. Our community is pre-approved because it is not something you can just buy. People asked us for the scholarship pass. The scholarship pass is for women, for underrepresented communities. So that one is on case-by-case basis, but you can definitely select this option. Has anyone already, because we talked about this last time, has anybody purchased this?
Not yet.
Okay, so yeah, I mean, people were interested in this, and they gave us this discount. So I'll post the link here, and you can get a ticket. Yes, so we have been given 10 tickets, and let me grab the code real quick. So when you put the code, you basically get 40% off of the entire thing. 1 second, let me grab the code. The code is, it was something like GG Friends. Yeah. So yeah, this is, I really highly recommend this. Looking forward to it myself. I'm very sure this will be an amazing event. So, um, yes, you do have an opportunity to book the tickets, but the price was $450. Now it's 500. It will go up, and this event will be sold out, I'm very sure. So, of course, there are many IML events, but I tell you, I don't endorse anybody for anything, but this truly is the place to be. And then that's not all. If you're in New York, you can come and meet Maddie once again. We are continuing our Google I/O extended series because there were literally hundreds of announcements, each one truly like an entire product or an entire new field. So we do have Power Women in AI ML next week on Wednesday at 5 p.m. at Google NYC. It does say Power Women because the speakers are women, but that doesn't mean it's limited to women. Absolutely everybody is welcome. Maddie will do an interactive demo you have a chance to play with Palm. Let me post that link as well. So yeah, we're very excited about this. We'll also have networking, food. We're still confirming the speakers, but we always have fabulous speakers. So this is the event to sign up for. I posted that link as well. Open source AI, yeah, Maddie, big fan of open source. So I think that's enough with the announcements. Please don't forget to use the Q&A, and I'll give the word to Roya. How are you, Roya?
Thank you so much, Miss Anna, for all of these great events. I was just checking my schedule, see if I can make it. It's going to be a really exciting month. Hello all, and
Wait, which one can you make? Is there a chance to come to New York? Because you should speak, not just come, if you can.
I'm just like checking my schedule, see if any of those fall closer to the weekend, because if at the end of the week, there is a bigger chance that I can make it. But 12th, I think, is a Wednesday, so maybe I cannot make this one.
Oh, okay. Well, you always invited. We always love having you.
Oh, thank you very much. So sweet of you. So let me share my, and yeah. So can you see my screen right now? Just to make sure, confirming.
Yes. Also have a question.
Yes.
Where do we find this? Is it possible to have a link, please? I really appreciate it.
I will provide the link to share the slides with you, for sure. Of course. We are halfway done. We are on week 3, and on the lieu of having thread, I just added my thread account here. If you are interested, we are presenting as a part of GDG New York City, and so be nice. We are trying to like be respectful and collaborative and participate, which is all of you doing it anyway. So I just try to bring the code of conduct to follow the tradition of the slides. As usual, this week we are also going to examine where we are on this journey and then go over some of the exam reviews, some sample questions. There is room for question and answers. Some of the answers I might be able to provide, and we have Maddie on the board, so she's available obviously for your questions, and we will close this session by reviewing what would be essential for following based on this plan for next week. So where we are on this journey, yay, we are halfway done on week 3. This week is based on feature engineering and machine learning in enterprise. Some of you might have a different lab in here. It has been removed because the link is not available anymore. And about the exam, so right now we are just focusing on the data. This study will just go through all of the preparation and processing that we require for our data. Anything from acquiring the data, data ingestion, exploring the data in a format of EDA, and also how to design a data pipeline, building it, and how to apply transformation and feature engineering. As we have discussed previously, a machine learning pipeline starts with defining a problem and proposing a solution. So you would look into a business problem and try to figure out if you have enough of data to use those to basically come up with an answer. Then obviously it is the job for the machine learning engineer to build this data set and apply all of the transformation required, and then train the model and use it for prediction. As we have discussed before, this is not a linear task, and it is a part of a cycle, because at the end, you would always come back and try to adjust the problem statement and make sure that the data you have is good enough for your purpose. But before I dive in any further, I would like to hear your thought on this question. This is kind of a main essence of machine learning. So if you had to prioritize improving one aspect of your machine learning project, what would have the most impact? Would you be spending your time using the latest optimization algorithm? Or you would work on the quality and size of the data? Or you would go for a more complex and deeper network? And lastly, if you are interested in having a more clever loss function. Thank you for all of the answers in the chat. I give it like 1 minute to see if you have any other thoughts. So I see that consistently everybody is pointing at B, and that's the right answer. The idea is that your data is essentially tells you how good your model can be. You can work on optimization, and it would handle the convergence and the speed of reaching to that convergence. And going with the depth of the model, it really depends on the size of the data that you have, because if you do not have enough data, the deeper you go, the less chance that you have to tune your model. And lastly, I am a huge fan of loss functions, because I think you can curate your model to do exactly what you are thinking. But if you are between spending time on a loss function and having the capability of going for the quality and size of your data, data comes first. It can solve a lot more of the problem that a loss function could solve. So it's a better choice between the two. Okay, let's go back to basically the chart. So constructing the data comes to collecting the raw data. We previously discussed that, okay, this raw data can be anything. It can be voice, it can be words, it can be images, it can be basically tables of numbers or any other categorical value. Then it is for you to identify what are the features that you want to introduce to your model and basically how to label these sources. Another part of this scheme is for you to identify a sampling strategy and split this data. So how you want to break down your giant data set into a piece for training, a piece for validation, and a piece for testing. And then it comes to transforming the data. How to explore and clean the data and do the feature engineering. A lot of work that you are doing as a machine learning engineer or scientist would fall into these two steps. Basically, you want to understand the data and you want to go through it and explore and clean it because dirty data would not work for you. They say garbage in, garbage out. It's also applicable here. If you have good input data, you can get good quality, high quality output. But if you give your model bad data, if your data is biased, if your data is not representative of your real world scenario, then the output that you are getting is not valuable. Although these steps that I explained might seem challenging if you are just looking to do it with maybe like NumPy and Pandas, Google has provided us with a lot of basically platform and tools to enable you to do it more seamlessly. So the first step that we discussed was ingesting the data. So for transferring the data, Google can provide you with transfer services like Google Cloud Services and PubSub. For exploring the data, you can use something like BigQuery because it allows you to essentially go and study the data. You can use data prep, data flow, data proc, and many other basically tools for preparing and processing the data. There is also Google labeling, which allows you to have data annotation without you spending money. And I think it will come later in this course and in the future sessions that labeling the data can be really expensive. So this is a good tool for you to use. Aside from basically automated labeling, they also have manual labeling under the hood that we can use, obviously, for a cost. And for the rest of your machine learning pipeline for training, hyperparameter tuning, and testing, you can use other Google tools such as the cloud or Keras or basically other Google tools. But I'm talking about data a lot. Why we have to have these tools for validation of the data? Why the data comes really significant? Traditionally, in an IT system, when you were trying to basically build your system, you had an input and output, and you were trying to build that algorithm that can map your input to your output. So to test your algorithm, all you needed to do was, or basically a smart engineer would think of good unit tests that can cover all of the corner cases. If you were able to build an algorithm that covers and maps correctly the input to the output, even for the corner cases, you were good to go. But machine learning does not have an algorithm that you can check. You have basically a set of data. You are allowing your machine to go through those data and figure out what is the pattern and use that pattern to predict for unseen data. So there is no such a thing as basically doing a unit test. I want to add a note here that there are some simple tests that you want to make sure that the system is working, but you cannot essentially have a specific fixed unit test for your machine learning to make sure that it does generate the proper answer. So you can input your model. I'm a person who works with computer vision, so I can input my computer vision system with a noise, just a noise or just a flat zero image and see what is the output. Based on my information about my model, I can expect some sort of info, but that never tells me if my system is working well in corner cases. That is the reason that you require to have some sort of data validation to make sure that your system is working well and you are covering all of the cases. For that to be covered, TensorFlow Extended is basically giving you an umbrella of all of the pieces that you are requiring. So in this session, we are actually focusing on TensorFlow data validation, which is a really handy tool to enable you to go through the data and make sure that the data, the input data and your validation data is the way that you're expecting it to be. TensorFlow also provides you with transformation and also estimator for class, data analysis, serving, and logging, which would be falling into the future sessions of this work. So why do you need a pipeline API? The reason for that is data might not fit into the memory. And it is funny to say because like 6 years ago, that was a huge issue, especially in a computer vision task, because a 3D image would not easily fit. Or you might require to apply some sort of pre-processing. So you want to have this pipeline to apply all of these other methods, other transformation to your data. You also want to be able to effectively use all of the hardware that you are utilizing. So if you are having 2 GPUs, you do not want to have one of them idle while the other one is using. And you want to make sure that you are using all of these idle slots in the middle of your processing. Let's dive deeper. So TensorFlow input pipeline allows you to do extract, transform, and load. So by extracting, you are reading your data from memory and you are parsing it into the format you want. By transformation, you are applying all sorts of pre-processing that you require. So if it's a text, you require vectorization. If it's image, you require transformation. If it's video, you require temporal sampling. And then you also need to be able to basically shuffle data, batch the data, break data, and apply many other transformations that it's not being discussed here. And then you want to basically load all of these data, transfer to your accelerator or GPU. There is an interesting plot on the right here, which is over time in history, plots how the capacity of the CPUs are differing from the GPUs. So flops is actually floating point operation per second. And it tells us how much innovation has happened in each of these hardware. Although the expectation was that the flops for CPU would be increasing linearly, we are getting to a point that it's getting to a saturation. However, the flops for accelerators, such as GPUs, it's still linearly increasing, which basically leads us to go and start using GPUs, which obviously that's what we are doing. So before going deeper, let's have an example. This is a really simple off-the-shelf way of basically generating a data pipeline. Let's read what it does. So obviously you are importing the TensorFlow. You are generating a black box for now, which does your pre-processing. And then you have tf.data, which is your base library, .tf record data set, which allows you to read data from a storage in a format of tf record. The next line does everything that you expect your model to do in this basically pre-processing function, to apply all of those, map all of those into everything that you are reading in your previous stage in the data set. And lastly, you want to batch this data for training. So we discussed it before that every time we are just feeding the system with a batch of data, eventually you will get this data set object and let your model to use it to be trained. But I was talking a lot about how we can make it more efficient to make sure that we are not having any idle time. If you just use the lines of code that I provided, the thing that's happening is that your CPU works and then your GPU is not working, or your CPU, your accelerator doesn't work. And then they switch places because you have a pre-processing part and then you have a training part, and they just bounce between. You have idle time. You can actually optimize your system to kill all of the idle parts that your CPU has. So you can just squish it all together, which helps you a lot with time. The way to do it is actually to add one simple line of code to prefetch for a buffer size. It allows you to, every time, if I go back one, so you are prefetching at the time that a training is happening. You are actually prefetching, bringing this data one slot back. So you are using your time twice, obviously. I mean, parallelly, in parallel. The other, still we have a lot of idle time. So even if you do all of it, you cannot save, you cannot do all of the optimization that is available to you. Another method of optimization is to have parallel transformation. So for the work that your CPU is doing, instead of just having one thread of work, you can have it to work on multiple threads, and to have a parallel mapping and pre-processing on your CPU to basically use a much longer, a much shorter time. For that, there is also another one-liner here, which when you are doing the mapping for the pre-process, you are inputting number of parallel cars, tf.data autotune. Recently, I've been using it, and sometimes it gives me error, but it works with the real number, like 64 or 32 based on your CPU. But it basically allows your CPU to work on multiple threads without you writing a code to do it. Next is for you to not only do the mapping and pre-processing in a parallel manner, but also do the data extraction in parallel. So initially, we were just like reading the IO, but we were like prefetching them. But still, despite prefetching them, they would come one after the other. What if we use all of the cores that we have on the CPU to make sure that they are being fetched in parallel? To do that, we are adding another parameter, another argument when we are loading the data. So now we are calling the number of parallels with some n number that you can put. So n is a real digit. So With that being said, now we have a dataset object ready to go. But before we go, we need to go and dive deeper into the data. Make sure that the data looks as good as you're expecting it. TensorFlow has this very cool tool called TensorFlow Data Validation, which allows you as a developer to understand, validate, and monitor your data. And it lets you to have this significant, giant data set and just like looking at it as basically visualize it really easily. There is a video for it, so I'm gonna stop. I need to share this one tab. Yes. Okay. So this is an example which I really like to go through. Let me see. I think it's the biggest one I can get. Okay. So that's a demo, and I recommend to go through it later, but essentially you are reading a CSV file, and it allows you to read it from a data frame, similar to what would you do if you were using pandas, and go through the table, and everything looks nice. You have your timestamp, you have your payment type, everything is there. This is not the cool part of it. So you let it a little bit go, and voila, it does compute a statistic for you. So it allows you to generate a statistic from your CSV file for your trained data. Up there, it breaks down the data into a training set, a validation set, and a serving set. You can visualize your statistic, and you can see in the side what is happening, what is your data distribution, if it is number, what is missing. I believe right here, your second column is everything missing. So for example, for dropout census tract, 28% of your data is not real values, and those are missing. And it also allows you to do the same thing for the categorical feature. So up there, it was a statistic for numeric values, but here you can see what is the for the categorical. So in red, you see that 100% of your pickup census tract are missing, and 34% of the company values are missing. And for example, the payment type is majorly in cash, but this is a red flag. So you want to expand it and see what is happening in your data. So you basically go through them, make sure everything looks good, and fix those that requires fixing. And as I mentioned, payment type is cash, and then credit card, and so on and so forth. Another thing that you can do is to compare between your validation data set and your training data set. So this is, I believe we have discussed it before, that when you have your model, you want your validation data set to be basically following the same distribution, but also to follow the distribution of data in the world. So you want it to be representative of the real world data. And I also mentioned, I think before, that suppose you are making a recommendation system, and a really nice for movies, and you are constantly using this data from previous time, basically historic data, and you are trying to continue with your work, but over the night there is this hit movie or series that really changes the taste of all of the audience, and now your data is not representative of what is happening in real world. So essentially, you are having a shift in the data. This TFDW or TensorFlow data validation allows you to see all of these shifts and drifts in your data. So first, it compares between your training and validation data set. And in the blue, you see the validation data distribution, and in orange, you see the training data distribution. The expectation is, or what we want to happen is to have them following almost similar distribution. So the validation would be a representation of the training. If we see difference, like this red one here, we want to go down the path of basically identifying what is happening. For example, here in this example, there is a difference actually. So for value down here, you see that there is a big difference between what the training data has and what the validation data has. So we need to go through those and make sure that, like, basically identify what causes this discrepancy. And I discussed drift and skewness. So basically this shift and drift into the distribution of data right now and the historic distribution of data. And for that, now we have this serving statistic, which is the data for right now. I think it's, so when you apply it, it will nicely plan out what is the skewness and what is the shift between the categories that you are asking it for. And it's, I think that's a really cool feature to have in your arsenal in the time of need. Okay, back to the slides. So far, we talked about the data. We talked about all of the bits and pieces that TensorFlow gives us to be able to load this data into our system. And we talked about how to use TensorFlow data validation to our benefit to make sure that our system is working to what you are expecting it. Next is feature engineering. Feature engineering, I think that's the art of machine learning. It's for you to learn where to put your finger to make your model understand what you want it to be able to understand. And it gets back to it all depends on you going back to your data and understanding your data as a human and going through the data and seeing what you are seeing to make a decision about a snippet of the data. And basically translating all of that information, all of your humanly information to something that is meaningful to a machine. But few of the standard way of basically feature engineering are those that you can see here on a slide. From the left, the most basic way of features is numeric feature. Those are basically features that are just a number. For example, somebody's height or the population of people in a town or the salary of somebody. The next one is categorical feature. So now you need a little bit of basically pre-processing because a machine, your system does not understand red, green, or blue. Traditionally, there is this method called one-hot encoding, and it gives you a vector of cells, and the length of that vector is similar to the length of all of the categories that you can think of. So here you have only 3 categories, red, green, and blue. The length of the vector would be 3, and the location of these mapping between the cells and between your vocabulary is important, because every time that the middle cell is actually flagged or is a 1, you know that your object has the characteristics of being green. And obviously, if the first one is 1 and everything else is 0, then it's red. Here in the one hot encoding, we only have one cell with the value of 1 and everything else is 0. You also can bucketize your system. This is where you have a number, but you don't want to use that number as is. It does not convey the same value that you are thinking about. So, for example, instead of going to so much precision, for example, for somebody's measurements, you can bucketize it, quote unquote, or quantize it into different categories of medium, large, and extra large. So now you are deciding that from this measurement to this measurement would fall into a medium category. From this measurement to this measurement falls into a large category. And then you are using this bucket for a one hot encoding, similar to what we did for categorical data. This is where you are having the numeric value, but you do not want to carry the same precision across your model. See, another interesting method that you can use is cross features. You would use it when you, first of all, it is not when you have so many features that you cannot already fit into your network. So it can be more applicable to, let's say you have a retail vector, retail work that you are working on. Then you are trying to use the correlation between the features. So you are trying to see when red and medium together would basically cause your system to make a certain decision, or when red and large cause the system make a certain decision. So if the length of this new vocabulary, which is actually the multiple of the first set of your features and the second set of your features, if the length of all of these vocabularies is small, you can go for a one hot encoding. If it's bigger, you can go for something called an embedding. An embedding essentially takes your data into a latent space, into an imaginary space, and gives each dimension, each feature basically a dimension, and tries to basically locate your point in that latent space. But because this latent space has many dimensions, then it's easier to make sense of each of those values for your machine learning system. You also have the chance of reducing the number of dimensions in that latent space. So basically you are doing dimensionality reduction. If you have a really big feature set, you can use an embedding to reduce it to a tiny, small set of features. I want to say that you can use principal component analysis as a backbone for embedding, but it doesn't mean that embedding is a principal component analysis by itself. But you can hold on to some of the features that are more valuable, or you can just put your features together to carry the same meaning. Lastly, you can use hashing. That's when constantly through all of these columns, I was talking about the size of your vector set. But if you do not, you don't have enough information about how many, basically, what is the size of your vocabulary, then you can use hashing. So now the size of your vocabulary can be dynamic, can change. and still you have this fixed set of data to go to your machine learning system. A good example for that is when, for example, you want to, you have a restaurant and you want to see what is the customer satisfaction based on your employer. So each employer can have a tag, and then you can have a one-to-one feature having each of your employer be a category for themselves. But what if you have your employer leaving or somebody else adding? It really doesn't make sense. So instead, you can use hash table to drop them into different hash buckets. Okay. So these are everything that we are doing to different type of features, but there is also what you can apply to your numeric values to make them making better sense to your system. One of the major ones is linear scaling. It's essentially you make your data uniform to fall into a really smaller categories, because machine learning system, deep learning system are better with a smaller number, especially when you have a feature set with large number and a feature set with a small number. You also can use clipping, which takes away the long leg of your data distribution. If you have a set of data which goes for a long way, you can basically say everything above this maximum, I call it a maximum. Everything below this minimum, I call it minimum. You can also use log scale when your data have really distributed values. So you have something with 10 to the power of 5 and something with the value of 10. So these are in respect to your 10 to the power of 5, 10 is nothing. Your model doesn't even see it. But if you put them in a log scale, then they are comparable. Lastly, you can calculate the z-score, which makes sure that your system has a mean of 0 and a standard deviation of 1. Again, traditionally, we know that machine learning system work better when the system is uniform and have a mean of 0 and a standard deviation of 1. Also, it makes sure that you are not going so far from your 3 sigma. So if we have this most left picture as our raw feature, if we do a scaling to a range, so basically clip everything, basically divide everything by the maximum distance between the maximum and minimum, and subtract everything from the mean. Now, instead of starting from 5,000, we are starting from 0 because we are subtracting mean from everything. Also, instead of having 5,000 to 45,000 data distribution, we have a distribution of between 0 and 1 because basically we have the maximum value divided. We also can do a clipping and say, okay, I don't want to squeeze all of this data between 0 and 1, but I don't want to have all of these tiny bits for like 45,000. I want to go with 40,000, and that's the maximum. I just noticed that you are not seeing my cursor, and I've been using it a lot. So if you check out the second plot from the left, you see that the x-axis, instead of being from 5,000 to 45,000, it's from 0 to 1, and that's because we are dividing everything to the distance between the maximum and minimum, and we are subtracting the value of minimum. And it also in the same plot, the plot starts from 0 and 0 because we are subtracting the minimum. Now, if you see the middle figure and compare it with the most left figure, you see that the in the x-axis, the maximum value in the x-axis in the raw feature is 45K, but in the clipping version is 40K. And the population of data on top of 40K in the middle is higher than the one in the raw feature. The reason for that is it decided that everything that are higher than 40,000 to be fall into the 40,000 bucket. So that tiny bit on 45,000 in the raw features is now added to the 40,000 in the middle plot. The log scale, the fourth plot from the left, is when we are applying the log value on everything. So in respect to the x-axis. So now instead of 5,000 that you see in the raw feature in x-axis, you have 8.5. And the distribution, this histogram is different because the distribution of data now has varied significantly. And lastly, we have zero score. This is the most right figure. And that's when you are trying to have an average value of 0 and a standard deviation of 1. So you subtract the mean and divide it by a standard deviation, and this can be your final result. The last thing that I'm going to talk about today is the transform. We discussed doing the transform and how to make sure that our system is doing a good job in doing this transform, and to make sure that we are using all of the resources that we have. We also discussed how to use the data and how to do the feature engineering. Feature engineering is essentially applying some sort of transform, but where to put this transformation? You have three possible places basically to apply this transform and feature engineering. One can argue that they want to do it as a part of basically training pipeline. So after you are building your model and you are inputting your data, you want to do some sort of transform on that. It's really good, it's efficient, it's partially okay because it only can apply your TensorFlow method, but the red flag here is that it only allows you to work on the inputs that are inside your model pipeline. You might think, okay, isn't it what we really want? The problem that comes to picture here is that you are not able to look into the other basically features and make a decision. You are not able to have an average of everything that comes into the picture. You are not able to use a sliding window because you just have this one snippet of data. To solve this problem, I go first with the extreme other end, which is number 3, which is doing this pre-processing outside of your whole basically TensorFlow. Now you can do anything that you want, and you can have this time windowing, which allows you to basically make a decision over time and see temporal data. But kind of the best of both worlds is if you use a TensorFlow transform. Now it takes the efficiency from doing it inside the model, and it allows you to do the time windowing or aggregating that is outside of the model. And the only drawback is it's TensorFlow method only, but sky is the limit with TensorFlow, so I don't think of it as a huge drawback. So let's look into it a little bit deeper. Yeah. So each stage your model, you can have your data, which is the station name, the start date, and everything. So basically all of your inputs, and have your transform, and then get all of the values that are interesting to you, quote unquote features, and then pass them to your machine learning model and get your output. Here it is, duration. This is an example of having the transform outside of your system. If you plot it, then it would be having the input, do the pre-processing, do the feature engineering, and then do the training and everything else. In practice, when you are doing it, it requires you to give, show your hand basically, or at least if it's the right expression in English, I'm not sure, but it makes you to tell exactly what you are doing with data to your client. And sometimes you want to keep your features to yourself because the feature extraction is the art of your machine learning knowledge. So here you are getting all of the input data, but you are trying to make all of the changes that you want out of that data. Instead, if I go next, instead you can now bring this transform block inside your machine learning model. So here in the red, you would generate this machine learning basically a schema, but the inputs to that had to be all of the transformation. But now you are bringing it in. So the input to that can be the raw data, and your model actually does all of the transformation. And if you are interested in the TensorFlow graph, if you plot the TensorFlow graph, you would see that it would be another Lambda basically layer in your model. It's just like everything falls into together perfectly. And from our initial schema that I was discussing, that hey, we have this transform, we extract the feature, and then we have machine learning. Now we can have transform and machine learning part. Essentially, the feature extraction all fall into one category in your model graph. So it would be really seamless when you want to have your machine learning model actually be able to access to your client. You do not need to show them what you do because that's your own magic, so you can keep it. So by that being said, I'm at the end of this session. Let me check your questions before I bring questions. Victor asked about the environment to use for TensorFlow data validation. Truth being told, I'm struggling with it on my servers, and we are using, I think, TensorFlow 2.6. I'm still trying to see how to make it work in a practical, like at work or something. So if I get the answer, I will get back to you. Colab is using Python 3.11. That's an issue that I need to get back. Okay, the rest of the questions are based on the problem with Colab. I know that it's an ongoing issue. I just received another message from the QuakeLab support team, and they said everything is fixed, but I haven't checked myself. I will update you if I see progress. Okay, if you are all ready, and I have one question that we can look into together. Different cities in California have markedly different housing prices. Suppose you must create a model to predict the housing prices. Which of the following sets of features or feature crosses could learn city-specific relationship between rooms per person and housing prices? A, 3 separated bin features, being latitude, being longitude, and rooms per person. B, 2 feature crosses, being latitude, room per person, and being longitude, room per person. C, 1 feature cross, latitude, longitude, and room per person. And D, 1 feature cross, being latitude, being longitude, being room per person. So I give you 2 minutes or 3 minutes to think about it. Please put your answer in the chat. There is no punishment for wrong answer, just answer. Put something and see how it goes. So I kind of think he puts their answer. If nobody else wants to put out their answer, the right answer is actually, I love Anthony, that's E for sure. The right answer is actually D, being latitude, being longitude, and being rooms per person. So being value means that we are categorizing them. The reason that C is not right, which I would say that in my opinion, that would have been the most plausible one, is because if you just go with the values for latitude and longitude, then the precision is too high, and because we want to do feature crossing, then it will be a gigantic feature set. I don't have enough of a good answer for why A and B are not right, except that when you are in D, you are making basically a correlation between the location of the house, basically the area, and the number of rooms per house in that specific area, rather than just putting a latitude and longitude separately, which does not convey the same meaning as if there is a specific area. That would be my logic, but if somebody has a better answer, I would be happy to pass the mic. Somebody asked why it has to be beamed. Suppose that the house has more than 4 bedrooms. You are not interested in everything that has more than 4 bedrooms, because the population of those would be really small, and everything with more than 4, for example, here can fall into the same category as 4. So you can have 1, 2, 3, and 4 bedrooms and above. To answer A, that's I don't know for a fact, but that's what I'm thinking, that the association between the latitude and number of room and the longitude and the number of room is not as meaningless as the association between all 3 of them. I think the more grammatically and English correct way of saying it is that having latitude and longitude being associated together gives you a geographical location, thanks to Cheng Tan. And if I said the name wrong, please forgive me. I'm bad with my English pronunciation, let alone saying name. Okay, thank you. I appreciate it. So I'm open if you have any questions here. And Maddie is also still here. If you have questions for her, please let us know. And given that it's just 10 minutes left, I don't think that we have enough of time for a lab. But if there are enough of interest, I can hop on to the next session, which is the office hour, and solve one of the labs online for you. Well, thank you very much. Love you all so much. And before we leave, so next week, please do the feature engineering and machine learning, and follow the learning journey because it gets tougher. And actually, this is the last session that I'm here with you as an instructor. I learned with you guys. I really appreciate you staying with me with all of the flaws and mistakes that I make. Thank you for this opportunity, and I hope that we get to meet in person in the graduation party. Thank you.
Absolutely. That was awesome, Raya. You're such a specialist and so helpful to everyone. So I hope everybody signed up for next week. You know, we always meet at 4 p.m. Eastern. The recording is always on YouTube because we are simultaneously streaming, and it's also on the event page. So each event page has a wrap up, and after the wrap up, it's actually all Linda's work that she posts and she records everything. Yeah, Roya, we'd love to see
Yeah, I
you.
will take care as soon as we finish.
I'm sorry. Oh yeah. So Linda is she does it all. Back end stuff you don't always see, but always very supportive. So yeah, there will be a recording available right after we finish. So we have two events next week. One is on Wednesday in person. We are going to post the finalizing the speakers and the agenda, but Maddie's going to make the effort to come to New York again, since the title is Power Woman in AI, and she is a power woman in AI. And we'll have other speakers as well. Yeah, thank you for everybody who's been helpful. Louis and MA stands for, would you like to share who is MA? Mary, thank you, Mary. I hope your profile on Cloud Skill Boost says who you are, because these are very, very advanced labs and your achievements. So it's good to know who did them. Please, yeah, keep up. I think this is truly a fascinating field that moves so fast. Literally every announcement at Google I/O was about AI. So I find it very exciting to be in this field now. It's truly revolutionary, changing entire industries, and you can be at the forefront and change your life and career. We almost at time. Are there any questions? There are no more questions that are unanswered. And give shout out to all the Google Cloud Associate Engineer graduates and the ones who got certified. They're doing extremely well. Here is, I see Aniket is here, Shafan. They all know the quality of the course, and they take time, and they continue on improving and being better every day. So that's awesome. The Slack channel, let me share the link again. Unfortunately, the Slack doesn't allow me to invite people, so you have to one moment. So you have to join. 1 second. For those who are new, we welcome everyone, but please start working on the labs. You see, we've posted what you should have achieved by now. And one moment to create the link. So yeah, we want everyone to graduate, to get a voucher, and most importantly, become a professional and have a certificate to show for. So please dedicate. We asked everybody to plan to dedicate 20 hours a week, and that definitely will be needed going forward. Any other questions? Invite people.
Can I ask a question?
Sure, yeah. Always feel free to speak up. You don't need to chat. You can even share your face if you wish.
So I have the channel called not the channel, the Slack called Road to Google Developers. But within that Slack, I have channels, other channels. But what is the channel name? I only need the channel name. How to add the channel name?
Right. So the channels are usually dedicated to each certificate.
Yeah.
So I highly recommend joining Cloud Machine Learning English.
Oh, okay.
Because that's what we're doing.
Oh, I see.
But on top of that, we have a dedicated Road to Google Cloud NYC. So this is our communities there. So both of those are super useful, because we want to have our own community within the Road to Google Developer Certificate. But the Cloud Machine Learning English is basically everyone everywhere in the world who is doing the same work. So chances are you'll get your questions answered there. We do have, like I said, going forward, we'll have Maddie take over and be the main instructor, but we also have Google developer experts in ML who'll be joining the office hours, and they will be joining the Slack. So we have our own professional help, but the cloud machine learning also has very capable instructors and learners, and both are very useful.
Okay, I think I'm now joined. So is this the channel with 230 people? Is this the channel you are talking about?
Yeah, Louis and Maddie listed them in the Slack.
Yeah, I know, but that link. So let me
Cloud Machine Learning English, that's the one, that's the certificate we're doing.
Yeah,
So,
I just typed hello. Is that the same channel you are talking about?
yes, Apple.
Oh yeah, okay, thank you. Then I'm in now. Thank you. Yeah.
Okay, good. And then also the Road to Google Cloud NYC.
Road.
Because we post things that are applied to our cohort in particular and answer questions there as well. So it's good to be. Cloud machine learning is more general for anyone taking the course, and Road to Google Cloud NYC is for the GDG NYC community.
Okay, I see.
Hello.
Both channels, yeah, both channels.
Hello.
Yes.
Yes, I'm Johannes. I can't see that Go Cloud Machine Learning on the Slack channel. I would like to join. I can only see Cloud Architect Architecture English, but for machine learning, I can't see it.
Well, if you there's no reason not to see it. If you
click on Add Channel,
browse channels, if you go on the browse channels, then it should be visible there. I can see it. It has 232 members.
I don't know why I cannot see it.
Are you in the Road to Google Developers Slack workspace?
Yes, sure. Yeah.
rgdc-google-cloud.slack.com.
No, this says maybe let me share the link that I'm in so that you can see if it's the right one. Can you have access to that link? Maybe if I've joined the wrong link, that's the link that I'm using, the one I've shared right now.
Right. So, yeah, under channels, you should be able to add that channel.
I don't know why on the.
You are under Cloud Architect English, is that correct?
Yes. Cloud Architect, yeah, English.
Are you saying
yes.
you're not able to add Cloud Machine Learning English?
Oh, yeah, okay. Is one on the list here? Cloud
Yeah,
Architect.
you need to add it yourself. It's not visible by default.
Okay.
You have to search for that channel, and when you search,
Oh,
you
okay.
will find it. Okay.
Okay. Is it among these links that are shared on the Cloud Architect English? I can see three links that are shared here.
We can't see what you see. If you want to share your screen, we may be able to help you.
Okay, let me share my screen.
We can stop the recording, Linda.
Yes, that's my screen.
Okay, I will do.
Thanks. So under Add Channels, do you see one plus where it says
Yes, I
Add
can see
Channels?